Hello and welcome to Nikolai's genetics lessons, and today I have prepared two, usually I say easy true-false questions for you, but this is not the case today. The first statement is rather controversial, and let me explain why. So, population parameters indicate estimated values of population. What is the population parameters? There are two types: true as opposed to estimated measures are termed population parameters. Examples include true population means, variances, and standard deviation, true correlations between traits, and true heritabilities. On the other hand, sample statistics estimates population parameters. They are derived from the sample data taken from population. Examples include heritability estimates, estimates of the variance, and so on. So let me give you some example. For example, variance, sigma squared, and estimated variance would be sigma squared and hat. We have a word estimated here, so that means hat. Imagine that this circle represents whole population, and this small sector would represent a sample of this population. And we say the whole population is going to be n. So n stands for the number of animals, and then sample would be n minus 1. Statisticians are usually very careful about the distinction between parameters and statistics. Animal breeders, even academic animal breeders, are typically less finicky. We do not know exact values for population parameters. We only have access to sample statistics, yet we readily substitute statistics for parameters and often speak of both as if they were the same. So from the point of view of the breeder, variance equals to estimated variance. But from the point of view of statistician, variance and estimated variance is not the same. So let's read again. Population parameters indicate estimated values of the population. And this would be true if we would say population parameters indicate true values of the population. So, because we have estimated, we have to choose from the point of view of the statistician that this is false statement. But again, in animal breeding, we almost never work with the whole population, only with a sample. We probably would know parameters of the whole population if the population would be on the age of the extinction and the number of animals would be small. So in animal breeding, usually we work only with samples and not the whole populations. So usually true and estimated values are the same. So animal breeder would probably choose answer that this is true. That's why I cannot give you the one answer to this statement, but at least now you understand the difference, and if you would have such a question on your exam, you can ask your professor from what point of view he wants you to choose the answer, from the point of view of animal breeder or from the point of view statistician. In this case, answers can be different, but I would prefer to choose that this statement is false just from the point of view mathematics. And next question: if we change gene frequencies in population, the mean breeding value and performance of the population were increased. Is it true or false? First of all, I want to change some words here, not gene frequencies, but allelic frequencies. And alleles defines breeding values. And some alleles can increase breeding value, and other alleles, if they would increase in their frequency, would decrease breeding value, which is individual parameter or characteristics, but in a population we can find mean of those individual characteristics. So we have to choose the answer that this is false statement. mean breeding values can either increase or can decrease, depending on the allelic frequencies, whether those alleles that change frequency beneficial for breeding value or would be deleterious for breeding value. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day, and see you in the next video. Goodbye.